for coming to our session. My name is Bala Natarajan. I'm a program manager in Azure CAD team. CAD team is basically working with customers for their architecture and technology. I focus on Azure networking and basically hybrid networking. And I work with a lot of customers throughout the world. And whenever we have some challenging customer scenarios, I get involved in one, to unblock the customer problems, two, to learn something from customer deployments also. So maybe we have a gap in our offering, and so what is that I can learn from that, take it back to our engineering, and so that we can add new features to our product to make sure that customers in the future don't have the same problem. That's my role. I have Balaji. He's a PFE, Premier Field Engineer. He is based in Melbourne. He and I are going to talk about ExpressRoute and how customers use ExpressRoute to provide connectivity. That was the original goal of this session. So when we thought of this session, why don't we actually include all of Azure networking, right? It's not Azure networking, the hybrid part, majority of customers want to know more about ExpressRoute, that we will be covering that. So we thought we will also include all other Azure networking scenarios too. So how many of you attended my session yesterday? So quite a few. So some of them, because I'm going to cover Azure networking also, some of them are probably looking like repeat, but this is for people who did not attend the session yesterday. I'll go through a little quickly. If you have questions, ask me. So the agenda is basically when I go and talk to customers, or Balaji goes and talks to customers, customer generally says, okay, hey, tell me more about your Azure networking features. That's not how the discussion starts. Hey, I have these requirements. What can you do to help me to meet these requirements? That's the customer's common ask, right? So, and then can you give me what is the best way to put together all these networking features? What's the right way to do? Do you have a reference architecture? Then obviously then question goes into ExpressRoute. So I'm trying to kind of mimic a customer conversation kind of thing and say what kind of challenges they face and how our features map to those challenges. And then we'll do a demo of an end-to-end connectivity, or basically the provisioning of an ExpressRoute circuit. That's a commonly asked question. So I thought I will walk through those steps and then answer any questions you may have. Then we have two customer scenarios, like real customer scenarios, and what all the challenges they faced, and what kind of design considerations they had, and how did we go about implement those two scenarios. We'll talk about those two. So that's the all right. So how do I map customer requirements into networking features? So first thing, customers ask, hey, I have these requirements. So for example, if I want to move my workload to cloud, there are you go and talk to the IT manager. IT manager brings somebody else from his team, my networking guys, security guys, maybe the business leaders from various teams. They all participate in the initial meeting and say, hey, these are the individual requirements. So one guy will say, hey, I as an IT administrator, I will have to control just the network. I don't care about the individual workloads. It is their responsibility. They will do a majority of the work, and they will be paying for it. So any charging back should happen to those departments. So these are kind of a central in the business side. And then the security person will say, hey, we have policies. Hey, anytime we want to move our workload to cloud, we have requirements on what can go over internet, what can go over the private connection, and how do we meet those things. Then obviously I have so many branch offices or geolocations. I need to be able to connect to all those locations, and I need high availability for this connection. If one location goes down, I should be able to reach my on-prem sites through other connectivity options. And then when I go for ExpressRoute scenario discussion, obviously they are, because ExpressRoute connects to all three clouds of Microsoft, IaaS, PaaS, and Office 365, there are specific requirements, and people want to understand how do I connect to, hey, I have these challenges. I don't have IP addresses, or I am going with a certain provider, he is unable to connect. That kind of challenges come in. So these are kind of challenges or requirements for customers, and how do we address each of these? So trying to map it to customer requirements into a feature. So a business requirement, we talked about it yesterday, the hub and spoke model for a VNet. What is a VNet? Why we need VNet peering and things like that. So that is the, in terms of segregation of workload, segregation of responsibilities, and charging back to the respective department with their own subscription. And the central IT guy manages the security aspect of it, the addressing aspect of it, and the connectivity aspect of it. The individual departments can still deploy their workload in a safe and secure way and have connectivity to the on-prem. And that's the VNet hub and spoke model. We'll talk about that. And then to address the security concerns, we have features for network security group. For deep inspection, we work with third-party appliance vendors to have their appliance available in our marketplace, so they can use those appliances and address those concerns. And then probably this is another customer, like a large customer. He had something like various departments, and those departments are like almost like independent companies, even though they are all under one brand name. Each department, they don't necessarily talk to the other department, even in their on-prem environment. But as a network admin, the admin wants to have hybrid connectivity, and he is the guy who is going to design the hybrid connectivity portion. And at the same time, he has requirements to say, I am the central guy, I will provide the path, but this department cannot talk to that department. That is my on-premise setup. How do I mimic that when I go to cloud? So each department needs connectivity to on-prem, but only to their respective network. How do we do that? That's the isolation part. And then some people would want to say, hey, I want to be able to do the traffic inspection. I need to be able to maintain records of what traffic was allowed, blocked. So how do I do that kind of stuff? And some customers would have other requirements and say, even though I have my workloads in the cloud, I need to make sure they go to internet through my on-premises security appliances, right? So I have invested in some security devices there. So I need to make sure that, from the cloud, they come through any of the hybrid connectivity options and then go to internet through my on-prem appliance or proxy server or whatever they have. So these are security challenges, and then various connectivity options, like what kind of connectivity options we can provide, site-to-site VPN or ER. We will dive into those a little bit more today. And then obviously high availability part, like various locations. How do I connect if one location goes down? How does the inherent high availability nature of ExpressRoute helps them maintain the connectivity? And even if one of the location goes down, how do I reach the other sides? This is a major topic. First, in terms of even understanding what it really means, what are the requirements? Can you give me some more details about how do I connect from my on-prem to Azure PaaS or Office 365, either over the internet or over the ExpressRoute? What are the requirements, and how do I do the netting and things like that? We will touch upon those. So let's take a look at the first one, like a business requirement. how does the VNet answer this? Yesterday we talked about this a little bit in terms of VNet as is a boundary by itself. Anytime you need to communicate with a VM outside of the VNet, it needs to go through a gateway device. And that gateway device is currently kind of a site-to-site VPN, or everybody will have to go through public internet and come back in through a public web. That's another way. But the gateway, because it is still, even though it is still going through Microsoft Backbone, the gateway has a bandwidth limitations of 200 Mbps. So if you want to connect to VNets over a site-to-site VPN gateway, even though they are all within Azure, you can connect it to any other VNet in any other region, and the traffic will go through Microsoft Backbone. But because of the gateway itself has a bandwidth limitation of 200 Mbps, you have a limitation of bandwidth. That's a commonly asked customer question. So that's where we introduced the VNet peering. The VNet peering basically gives you the segregation. So for example, these could be two different departments, and they put their resources in their respective VNets, and because they have a business requirement saying that this guy pays for their workload with their subscription, and this guy will pay for their subscription and for their workload. But still, they need to be able to talk to each other. And that's what VNet peering gives, and it makes the two VNets appear like one VNet. And so they can simply route, and you get the full bandwidth of the underlying Microsoft Backbone. There are no gateways here, and so you're no longer limited by the 200 Mbps bottleneck. All right, so this is the typical thing. So a business requirement in terms of how do I, as a central IT guy, how do I control address space? The central IT guy could define their first hub VNet, and then individual departments can use their own subscription, and then say the central IT guy just gives the address space. Hey, use this address space for your business unit, right? And then, so because it is individual department subscription, charging back will go back to the respective departments. The central IT guy need not worry about a common charge and then finding who used how much, and he doesn't have that headache, right? So that's the advantage of this hub and spoke model. And also, now the central IT person can have a shared security appliance and say, hey, anytime these teams need to go to their on-prem, they will have to go through me, and I will make sure their traffic goes through their appliance. So it meets the security team's requirement, and say anytime traffic goes from the departmental VNets to on-prem or vice versa, the traffic can be inspected, and you can have any of your appliance of your choice. That also gives the ability to not repeat the firewalls in individual VNets, and you can have a common place that will help you to consolidate your cost into one place, right? So that is VNet peering, and security aspect of it within a VNet. How do I control traffic? So once you create a VNet, you have the ability to create multiple subnets based on your workload needs. Maybe one subnet is good enough for some people. Some people will need multiple subnets. And because they are all created under one VNet, the system route is a common thing. Like normally in your on-prem, when you create multiple subnets, you need some kind of a routing device to be able to communicate between the two subnets, right? Here, the system routes helps you to communicate between the subnets, but at the same time, customers would say, hey, I don't want a complete routing. I want to allow only some specific traffic to flow between my front end and back end, or I don't even want the guys to talk to each other. I don't want anybody to come from internet directly. So those kind of policies, you can do that through the network security group. It's basically a 5-tuple rule. So IP address, source IP, destination IP, source port, destination port, protocol, TCP or UDP. So that's what we call as 5-tuple rule. And it helps you create your DMZs and adhere to your policies like what you have in your on-prem. That's easier to do. Other things like gateway devices help you connect to your on-premises through either site-to-site VPN or ExpressRoute. I'm rushing through these things. And then another commonly asked question is, hey, I don't want any of my VMs in my VNet to go to internet directly, right? So the way to do that is if you have connectivity through ExpressRoute or through site-to-site gateway, from your on-prem, you can advertise a default route into your VNet. So all the subnets in that VNet are going to learn a default route instead of the default route going through the regular internet gateway from the VNet through the Microsoft backbone. Instead, they all will come back from here and then go through whatever cross-premise connectivity you have, and then go to your on-premise firewall or whatever you want to do with your inspection, and then get out. So that's these are requirements. It's not like hard requirements. Some customers have these requirements, because they have been practicing it that way in their on-prem, and they want to make sure they want to follow the same model in the cloud also. So we talked about NSG, and we said it's only a 5-tuple base, like layer 3 security thing. So you can only control based on IP address and port and protocol. Sometimes what may happen is, hey, I have applications and I want to be able to look at the packet, look at the incoming request, and say, I have a request coming in for contoso.com or fabricom.com. If I just control the port tackle and say allow port 80 or allow port 443, it is not going to be able to differentiate between a request for contoso.com or fabricom.com. It's going to allow both, right? And then the application gateway can actually now do at layer 7 inspection, and then look inside the HTTP request and say, what is the GET request? What is the URL that is coming in? And based on that, it can direct the traffic to any of your backend pools. And so you can do your, basically this could be something like virtual IP that contoso.com and fabricom.com resolves to. Maybe they resolve to the same IP. And based on the actual request, you want to redirect the traffic either by the domain name or by the request, like whether it wants to go to the /video site or /images site. Based on that, you want to be able to redirect to the respective internal servers. So that's what application gateway does. And one other thing is it has SSL termination. What it means is, even if it is secure access to coming into the appliance gateway, the appliance gateway can look at the SSL traffic, decrypt it, and then send that back to your internal servers in plain text, or if you want to do SSL again, it can still do the SSL again. So that is a new functionality that we added. On top of it, it's not just enough if I just look at the incoming request and redirect. There could be some malicious request coming in. I want to be able to inspect that kind of malicious traffic also. So that's the new SKU that we added, which is the WAF SKU for the application gateway. It basically has a set of rules that are based on the Open Web Application Security Project. So because we are aligned with that, we look at what are the top 10 threats that they advertise and take that as a predefined rule set, so that our WAF would be able to look at the incoming request and say, hey, this attack looks like a cross-site scripting attack, or this request looks like a SQL injection request. And so, and based on that, you can simply say, do you want to kind of detect just the request and log it, or you want to just block it? You have the option to do those things. So, and it also has like ability to log alerts, and then basically people want to be able to have a record of who came in at what time, so that for any offline inspection, they can also store those logs into the customer's storage account, so for offline analysis. So application gateway, web access firewall, this gives you even more security. All right, these are all great. These are Microsoft product, and the WAF gateway, basically it works on a core set of rules, right? There is no configuration that is available there. It is given to you based on what we know and what the top 10 threats are. But if you want to tweak it further, and probably you are used to your own appliance, and you want to use the same appliance here also. And in that case, like earlier I said, like within a VNet, you have multiple subnets, and they talk to each other based on the system route. Now you want to influence that routing and send the traffic through the appliance so that you can do even further inspection and say, hey, I want to use the appliance. So that is where the user-defined route feature will help with addressing the deep inspection request or deep inspection requirements for the customer. All right, moving on. The next topic that comes in is hybrid connectivity. We have two options. Either you can do a VPN site-to-site connection, or you can use ExpressRoute. Let's look at the VPN options. There are two modes of VPN operation. The older one, which we call policy-based, basically it is based on a fixed defined set of static routes, and say, hey, whenever you have traffic between this subnet to that subnet, put the traffic through the site-to-site tunnel. And then anytime your on-prem routes change or your cloud routes change, you have to keep on updating it. It's not going to learn automatically. So the newer one is the route-based one. It supports dynamic routing protocols like BGP. So it knows what is available on the other side of the site-to-site VPN connection, what is available on my on-prem routes, and any changes that happens, because it is learned through BGP, it can automatically tunnel the traffic through the site-to-site tunnel, and that's majority of the case. Sorry about the color scheme here. I think I imported it with this model, and basically what it tells you is, because it is dynamic, and you have connectivity between your on-prem location to one of your VNets, and within your cloud presence, you may have VNets across the globe, and you can have connectivity through any of your VNets. So for example, if you have VNet 2 and VNet 1 connected through a VPN tunnel, and then you also have VNet 2 connecting to VNet 3, VNet 1 connecting to VNet 3, if this link goes down, automatically route can go via on this place. That's because it's BGP. BGP will learn, okay, what are the alternate paths, right? And another thing is, if you have connectivity to another remote, from the another remote site to one of the VNets that is linked, now you will be able to reach from your on-prem site to the other site through the Microsoft backbone, through those VPN tunnels, right? That gives the transitive ability to go from one site to another using Microsoft backbone. All right, that's the advantage. And then other things these customers commonly say is, hey, I want to connect, but at the same time, I can't depend on one internet connection. I have two internet connection, and I want to be able to use both of them to connect to my VNets in the cloud. And can VPN do that? And yes, the VPN will be able to connect your Azure VNets through, maybe you have two ISP connections to internet. Through both of them, it can connect to the same VNet, and it can use both of them, or you can configure it in such a way that if one ISP, that's the main one, or the other one could be in a passive mode. If the active one goes down, you can connect via the backup one automatically. So that's possible with the active tunnel failover detection. Then other requirements are like, hey, I want to be able to connect from two internet connections to two different VNets, but at the same time, I want to cross-link each other so that even the ISP connection here fails, or one of the VNet link fails, I should be able to reach any destination from anywhere. That's a requirement. That is for business continuity reasons or failover reasons. People want to have this kind of setup, and that is possible now. All right. Going to talk a little bit about ExpressRoute here. How many of you worked on ExpressRoute and familiar with the terms of ExpressRoute? Okay, so it's still a majority not knowing about ExpressRoute. So let me just explain the basics of ExpressRoute. So like I said, first thing, ExpressRoute is a dedicated connection to from your on-prem to Microsoft Cloud. And and also it doesn't go through internet, it is a direct connection to Azure. And because it is direct connection, it's not, some customers have like financial sector customers, they want to move to the cloud, but they don't want to go through internet because it's a public medium. And even though they can go through site-to-site VPN, it is all protected, encrypted, but still their policy would say, no, it doesn't allow us to send any traffic over the internet. So they will have that kind of requirements. For those kind of customers, ExpressRoute gives them another option that says, okay, anyway, it is like any other my private WAN connection. I'm going to be, Microsoft Azure is going to look like another extended branch office to me, and it is a dedicated connection to me. Nobody else is going through that and all. So it gives me the privacy that I need. Two, I can buy a link of the bandwidth I want, and so I can have predictable performance, right? So it'll be consistent always. It's not going to be dependent on what other customers are doing, how much load they are sending through that. And so because it is your own highway, you know how much bandwidth you can get out of it. So that's another thing. Two is we provide a high level of SLA for the availability of the ExpressRoute circuit. The way we do that is you order one ExpressRoute circuit. In fact, you get two. You get two virtual circuits. And each of those virtual circuits can connect to the three clouds of Microsoft, Office, PaaS, or IaaS. And because you are connecting directly into Microsoft thing, we normally want to make sure that you are coming from a trusted endpoint, and we have partners like that, so worldwide. And that's the, from your on-premise, you will have connectivity to a partner, whoever is your local provider, and you will choose what Azure location that you want to connect, and you will tell the partner and say, hey, I want to connect to this region in Azure, and give me a connectivity. And there are various partners, maybe these are your local familiar names, and they patch it to our network. And it's just trying to show kind of demarcation in terms of who owns up to what point and things like that. We provide SLA for up to this end of our side, and you work with your partner for their end of the device. And then you have probably a last mile connection, a simple fiber cable to the partner's location from your place, or you could have your MPLS provider connect you to their end. So it depends. We call that layer 2 service or layer 3 service. Layer 2 service is something like a simple, look at it like the extended Ethernet cable. All they provide you is an extended Ethernet cable, and you configure the routing on both your side and on the Azure side. Whereas in a managed service, they are able to manage the provider, like a layer 3 provider would be able to configure the BGP routing protocols, and they will be able to configure the Azure side of the router interfaces and the routers that are connecting to your on-premise also. So that's the two model. And for exchanging routes between your on-premise to your IaaS network or PaaS or Office 365, it uses BGP. And so any changes you make in your on-prem will be seen by the VNets here. And similarly, any change you make here is going to be visible on your side also. Similarly for PaaS and Office 365. because it's going to be a BGP. All right. Then we talked about briefly force tunneling and split tunneling. That's a common term, like even from the VPN client scenario, like people will say, do I want a VPN client with force tunnel or split tunnel? It's the same concept. How do I do all these kind of things? So for any time you have cross-premise connectivity, what do I send through that connectivity? One, basically when you buy an ExpressRoute circuit and you have a virtual network to connect to, we call that as private peering. The private peering is nothing but connecting to your IIS cloud. We have 3 peerings for the 3 clouds. IIS peering is otherwise called private peering, which connects to your VMs in Azure. And so for that, you create a VNet, and then you create a gateway subnet, and then you create a ER gateway, and then the ER gateway is linked to your ExpressRoute circuit. The ExpressRoute circuit is connected to the customer network, and you can also kind of, we talked about this force tunneling scenario, what the default route advertisement from your on-prem to the VNets. That means everybody in this VNet is going to talk through this ExpressRoute circuit and get out. That's the force tunneling scenario for ExpressRoute. Other things could be like you can deploy appliances and create DMZ so that you can still inspect, or you can have appliances on both sides of your network and encrypt the traffic also. ExpressRoute is simply a layer 3 connection. It is private to you. That's why there is generally not a need for encrypting it further because it's your own connection. But some customers have a requirement saying that, hey, I still want to encrypt, right? But then in that case, you can put appliances on both sides and create encrypted traffic through and send it through the ExpressRoute tunnel too. That's also possible. Or you can have one ExpressRoute circuit to connect to multiple virtual network in your IIS. So the same ExpressRoute circuit can link these 2 VNets, and because these 2 are connected now through the ExpressRoute circuit, these 2 VNets can now talk. So they will go through the gateway and go to the ExpressRoute, the MSE router, and then come back into your own VNet. So you can now link 2 VNets not just by VNet peering. You can also link, if you link the 2 VNets to the same ExpressRoute circuit, then the 2 VNets can now talk between them, right? That's also possible. Another thing that to touch upon here is the VNet peering has a requirement that the VNets are in the same Azure region, whereas in this one, you can link, I'm sorry, didn't mean to go here. You can link these 2 VNets in same Azure region or different Azure regions or different geo locations depending on the ExpressRoute SKU. We have 2 SKUs available, standard SKU and premium SKU. Premium SKU gives you the ability to connect VNet across the globe. Like you can connect a VNet in US and Australia with one ExpressRoute circuit. If you have, that means you can learn the routes from other geopolitical regions also. That's the option here. And again, for high availability for ER, we said ExpressRoute comes with 2 circuits, and that's how we provide the high availability of 99.95% SLA. But on top of it, customers want to have a connectivity from different locations. In this case, I'm trying to show you like 2 locations, Sydney and Melbourne, have their own ExpressRoute circuit to their own Azure VNet in Australia East and Southeast, and they all have their own ExpressRoute circuit. And we have something like an address range for a Sydney region and 10.2 for the Melbourne region. And how does the routing work, and how do we have a high availability connection here? So what it tells here is because the commonly you also have some kind of your MPLS connection to connect your 2 locations, and so you will obviously have learned the routes of Melbourne in Sydney and vice versa through your MPLS network. And you can advertise those routes to the respective Azure network, right, through the respective ER circuit. And you can do that with a BGP AS path metric. These are all mostly routing tips and tricks. Nothing new for ExpressRoute here. Anybody who knows BGP very well will be able to configure it. So what they say is, what is the shortest path to reach 10.1 network? It is kind of given by an AS path number. The bigger the path, the longer the route. And if I'll always choose a shorter path first. If the shorter path is not available, then I will look for alternative path. So the AS path, you advertise a shorter AS path for Sydney network through the Sydney ExpressRoute circuit to the VNet. So basically, it helps the VNets in Sydney and also in Melbourne to learn what are the routes that it can learn from your on-prem network. So this is how the route table in the Azure ExpressRoute gateway looks like. It says I can reach 10.1 and I'm with a shorter AS path, and it is through the Sydney network. And you can reach also 10.2 directly from the Melbourne circuit. The reason, because I have connected the Melbourne circuit also to the Sydney VNet. So the two green paths are kind of shortest path for the Sydney virtual network to reach respective location, and the orange paths are the longer paths. So anytime this VNet wants to reach Sydney office, it can choose the local ExpressRoute circuit and reach your on-prem network. What happens if that connection goes down? Because I have, if the connection goes down, because it is all done through BGP, I will no longer learn those routes. And so the route table will take away those entries. And the only entry I have is for 10.1 is through Melbourne. So traffic will come through the Melbourne circuit and reach through your backbone to reach your Sydney on-prem. So that's the high availability option. So even if you have one circuit goes down, you have the ability to reach through your other circuit. This is a commonly asked question. I thought I will take some time to explain it so that you can design your network that way. Connecting to Azure PaaS and Office 365, we talked about this private connectivity to your VNets. Those are your address spaces. You can have private IPs in Azure, but when you connect to Azure PaaS or Office 365, they are kind of a public cloud. They operate with the public IP addresses. So when you want to connect to that, and the traffic need to come back to you, and so you have to connect to that with a public IP, and that's the requirement for the routers to say, hey, anytime the Microsoft PaaS service, because these are shared services, you are not going to own your VMs there, you are just going to own a service, you are going to run your service in PaaS or Office 365, and they run on public IP because people also connect to that over internet. And because you don't want to go through internet, you want to go through ExpressRoute, which is dedicated. You need to make sure that whatever request goes out of your ExpressRoute to reach those paths will come back via the same ExpressRoute circuit. So for that, you have to say, here is the public IP, and you advertise your public IP range to the PaaS cloud or to the Office 365 cloud, so they know, okay, your requests are coming through this public IP. I know about this IP, I can return the traffic through the same ExpressRoute circuit. That's why we have a public IP requirement. And ASN number is another thing, like another BGP term. You have private ASN, public ASN things. So to establish the BGP session, because it's going to be a public IP and with a public ASN, so whenever you want to have connectivity to PaaS or Office 365, you need to have public IP and public ASN numbers. Other things in terms of when you connect to PaaS or when you connect to Office 365, you are connecting to all the services within those clouds. So for example, You may not use all PaaS services. You may just use certain services, or you may not use the PaaS services throughout the globe. You will be using it only for a specific region thing. So you don't want to send all the routes, because it's going to be sending you a lot of route entries. Some customers don't want to learn all those routes. They want to kind of limit to what I want to really connect. I don't want to open it for everybody. And so they want to restrict what they want to allow through the ExpressRoute. So that is what is called community tags. Whenever we advertise routes from the Office 365 or the PaaS cloud, it comes with a community tag. The community tag for the PaaS cloud is location based. Okay, hey, I want to connect to Azure PaaS service that is closer to my region, and I will only allow routes with that community value that's local to you. Similarly, for Office, it is service based. So for example, in Office, you may just connect to Exchange Online. You may not use SharePoint or any other Office 365 services, and so people want to just learn only those routes. So we can control what you learn through the BGP communities, and that way you connect only to what you really want. We talked about route symmetry. The main thing here is because these are public services, accessible over internet and also accessible over your ExpressRoute circuit, the important thing to know is if you send the traffic through ExpressRoute, the return traffic will have to come via ExpressRoute. Because if you advertise your network's range over the ExpressRoute and also over the internet, then the Microsoft Cloud is going to learn that and say, okay, you have two paths, and it could pick the return traffic through the other route. And when that happens, you will probably have firewalls in front of ExpressRoute or in front of your internet, and it will see only one side of the connection, and firewalls generally block one-sided connection, and you will have connectivity failure. So that's important to know how you define your route advertisements. Whatever you advertise through ExpressRoute, that is exclusive to the ExpressRoute. Whatever you advertise over internet for your corporate range, you try to keep it separate. That's the point I'm trying to make here. I think we talked about this. One other thing is, this is another common question that we get is, hey, I don't want anybody from Microsoft PaaS to come back and connect to my corporate network. So PaaS peering by nature is one-sided. You, from the on-prem, initiate connection to PaaS, and then the return traffic can come through. And then because you are probably having a private IP range here, and you want to make it look like coming from a public IP, and so you have to do the natting on your end, right? It's one way. Then similarly for Office 365, we have various services of Office 365 you can reach through ExpressRoute. The important thing to note here is there are still certain services that are reachable only over internet, even though they are needed to access Office 365 like CDN and DNS. You need to make sure that you can reach them over the internet, and the actual Office services you can reach through ExpressRoute. This is two-way. Like, for example, Office 365 servers can initiate a connection back to your Exchange servers on-prem. In a true hybrid Exchange deployment, some user may try to set up a meeting request with another user. One user's mailbox could be in Office 365. Another user's mailbox could be on-prem. And so depending on who is setting up the connection, there may be a need for the Office 365 server to reach back to your on-prem Exchange server. So it will need to initiate connection back to you. So that is a two-way connection. And so you want to make sure that they are coming back. So to reach back your on-prem Exchange servers, what is the name that it is going to resolve? Is that name is that name resolved to an IP? And that IP, are we advertising it through ExpressRoute so that these guys can learn that IP could be reached back over ExpressRoute? So you need to worry about or plan properly with name resolution and how the route symmetry you can still maintain. And similarly, sometimes, depending on how you configured, you may use your on-prem ADFS servers for any authentication traffic. And how are you going to reach those ADFS servers? Are you going to reach those ADFS servers over the internet or through the ExpressRoute? That also makes it kind of design choices for you to say, how am I going to resolve name? Is that name going to be resolved only over the public IP range, or is that IP, it is going to resolve to an IP that is reachable via ExpressRoute, right? Things like that you have to plan. There are, I think there were a couple of even more deeper Exchange ExpressRoute sessions, so make sure you attend to those sessions, and that will give you, go more depth into this area, right? And the same, because it is going to be two-way, you need to make sure the natting happens on both sides. This is another touchy subject. Customers say, some customers say, hey, I have some VMs residing in my VNet, and I also have to access some of those public services. Can I reach them through Microsoft Backbone? Or some customers would say, I don't want that to happen, right? Again, there is no right or wrong. There is another constantly asked question, because there are a couple of things. One, normally, because ExpressRoute circuit can connect to all three clouds, if you link the same ExpressRoute circuit to this PaaS and also to the IaaS cloud, whenever you want to, and then probably some customers also say, hey, I want force tunneling, right? So from their on-prem, they advertise a quad 0, and a PaaS IP range is not part of your VNet, and so the quad 0 route takes over and say, even to reach your PaaS services, you are going to go back to your on-prem, and then the on-prem router knows, okay, I already have a peering with the PaaS service, and I have learned these routes, and the on-prem router knows, okay, these destinations can be reached back via ExpressRoute, and so the traffic goes from your VNet back to your on-prem router, and that router knows your IP ranges for PaaS, and it comes back to the PaaS through the PaaS peering of ExpressRoute circuit. So some customers would say, hey, I thought it will go directly. It's all Microsoft range, so why can't it go directly? These are design choices. There is no right or wrong way. You need to make sure that how you want to configure your network. That's what I wanted to share in this slide. And it's a common slide, so I don't want to spend too much time here. This is a general model. Whenever we want customers to look at it as kind of a common best practice kind of deployment model where, hey, you have a hub that is managed by the central IT. You have departmental VNets that are controlled by the individual departments. They pay for it. And then the hub VNet is the one that provides connectivity to on-prem. All your security appliances are in the central place. This is a common architecture that we recommend to customers. Say, look at it and design your network this way. All right, at this point, I want to take a break and show you a live demo of how do I provision an ExpressRoute circuit, what are the steps that you have to go through, right? What are we doing on time? 10 minutes. I'm sorry, 10 minutes. Totally 10 minutes?
Okay, we'll see. Go with it.
Okay.
Try to do it in like maybe 4 minutes or something. I will speed it up.
Oh, okay. All right. What I have here is, oh, what happened?
6.
Let's duplicate. This is 6, right? Oh, sorry. Okay. This is my already provisioned ExpressRoute circuit. With one circuit, I have the private pairing enabled, And so the way I have done that is basically when I go and configure a new ExpressRoute circuit, so I go to Azure portal and add a new ExpressRoute circuit and say networking ExpressRoute, and it says what is the name that you want to use for this circuit, and then it asks you who is the provider that you are going to go through. Let's say test one, and then it gives you a drop-down option to select whoever is your provider, and then what is the peering location that you want to connect for Equinix. And I'm from Redmond, so I'm going to choose Seattle. And what is the bandwidth that I want, and what is the SKU that I want. We talked about two SKUs, a standard SKU or a premium SKU. I choose what I want, and then I want an unlimited connection, or basically ExpressRoute, you pay for the amount of data that you are going to send out from the Azure site to your on-prem. Do you want to charge based on what you use, or you want some kind of an unlimited plan? So this is the metered plan. This you will pay what you used, and then it is going to ask for a subscription, like who is going to pay for it ultimately. That's the subscription that you choose, and what Azure region that you want to create this circuit to, right? I select US West. Then once I create the create button here, what I'm going to get is service key, right? That's the service key I have. Since I have already provisioned, I'm not going to create a circuit here. And so I have created that circuit, and I got a service key. And so the next step that I have to do is I have to go to my, because I chose Equinix, and I'm going to say, what is the metro I want to connect? Let me start a new thing. I think it timed out. When I log into my portal, you get an account, and then since I connected to Seattle, and it gives me all the circuits that I own. And remember, the ExpressRoute circuit comes in two. There's primary and a secondary. And I'm looking at the primary configuration here. And then I am going to take out the service key that I caught from the Azure portal, and I'm going to supply that service key here so that Equinix can link your circuit to Azure using that service key. And then it also asked for certain parameters like the VLAN ID, because it can connect to all three clouds of Microsoft. Each one you can define a VLAN ID. In this case, I'm using an arbitrary number 100. I'm going to connect to my IaaS cloud, and I will use that same 100 in my Azure portal for my IaaS peering. That's the VLAN ID. And then it also says, okay, how are you going to actually send this VLAN traffic through the Ethernet medium? What kind of queuing mechanism that you are going to use? Is it .1 queue, or is it a queue-in-queue method? So this setting is mainly between your router and the Equinix configuration. We don't worry about what you use between them. It's just for you to make sure that your routers can send the proper VLAN ID to the Equinix side, and then when it comes out of the queue, they can understand, okay, you have 3 VLANs or you have only 1 VLAN, what is the VLAN ID? They can learn all those things, right? So that's the VLAN ID here. And I then go to my router and configure the same thing. So in my router, I say whatever queuing mechanism that I used, and whatever VLAN ID that I'm going to use, and what is the IP address for my primary interface that I'm going to use. And since I have not enabled the peering for PaaS or Office 365, I have not configured anything there. And this is the secondary interface that I'm going to use. for the second ER connection. And similarly, there also I'm not using any Office or Microsoft peering, so those interfaces are down. Basically, the physical fiber that comes to your router, it comes to the WAN interface of the router. Within the WAN interface, you create multiple sub-interfaces, one for your IIS peering, one for your PAS peering, one for your Office 365 peering. So those are the sub-interface IDs that we use, and the VLAN IDs, and what is the encapsulation method that you are going to use. So whatever you set in your router, the same thing that you have to use in your provider's side, and whatever VLAN ID that you use for your private peering, you are going to use that to in the portal also. So let me look at the portal private peering settings, and I use the same VLAN ID in the Azure side, right? And because these are point-to-point connections between your router into ER router, the IP addresses that I use for my primary and secondary interfaces will have a /30 mask. So the first address of the /30 will be used by your router, and the second address from that subnet will be used by the Azure side router automatically. So that's what you are configuring, and say what IPs that you are going to use and what are the peer ASN ID, because for these things are going to establish a BGP session, so you need an ASN number on your router side and also on the Azure side, and the VLAN ID that you are going to use for this. So that is what the configuration looks like once this is done, and your router is also configured with proper IP addresses and AS number and BGP configuration. Then they can establish the BGP session and start exchanging routes. Okay, how do I know that this is actually done? So we have added support for basically making sure I am able to see the other side of your router from Azure side. So if I go to my circuit and look at the ARP table, basically it is going to take some time and populate the MAC addresses of the Azure side and also your side. And when I see the MAC address, that means my connectivity end to end is good, right? And then you can also do that for, so it says, okay, your on-prem IP address of your router is this. I'm able to see that. And this is the MAC address you have on your router. And this is my MAC address and my IP and MAC address. And similarly for the secondary circuit, because there are two circuits here, a primary and secondary, it can show. And then because the session is established, now I can see the routes. What is that I am advertising from the on-prem side? What is the route I am advertising from the Azure side? You can see those route entries also. This basically gives you a confirmation that you have set it up correctly, right? So it's going to take some time to populate these things. While this, it took some time, okay. Another thing I wanted to show you is this is my on-prem range, and it says to reach your on-prem IP range, this is my IP range. It says the next hop is 1.1. 1.1 is the on-prem end of the Azure ER router, right? And this is my VNets in Azure. The VNet, I have two VNets, a hub and spoke. The 10.101 is a spoke VNet, and the 192.168.2.0 is the hub VNet. This is where my ER connection is terminated. And it says I can reach the 192.168.2.0 through 2.77 and 2.76. Why do I have two IPs? Remember, I said I'm providing high SLA, right? The high SLA, because on the ER gateway, even though you saw one, I already have two, right? Even if one ER gateway goes down, my other ER gateway will provide you the connectivity. That's why I have two IP addresses here, 77 and 76, right? So these things you don't configure, you just say, I want an ER gateway. Behind the scenes, we provide two, and that's how we maintain the high availability of your circuits. And then similarly for my spoke VNet, I can reach through the same ER gateway. Basically, the router at the MSEE end of the ExpressRoute sees these routes from the Azure side and as well as from my on-prem side, and it says, what is my next hop? How do I reach the other side? That's what this gives you. So that's what I wanted to show in this demo, just to give you a quick intro. And then, Balaji, you can take over and talk about the customer's case.
Okay, we've got a couple of customer scenarios that we want to go through real quick. The idea of the customer scenarios is to show how all the things that Bala just showed you, how we applied it in the real world, and hopefully you'll be able to learn from that.
Right. Just my next one.
Okay. The first customer scenario is coming from our team, Microsoft team in Europe, where they work with this large retailer in France. They're based out in France, but they had offices all over the globe, so the solution required that they are connected to all over the Azure regions they're going to use. So we went through a bunch of business requirements and technical requirements. In terms of business requirements, the summary is they wanted pretty good redundancy. They wanted high availability. That was the theme. And they wanted to do it in phases. So they wanted to test how we do it in France, and providing that works well, they would like to move that to Europe and then to the worldwide regions, right? So, and in terms of technical requirements, it pretty much syncs with what they said. They wanted high availability, right? In every component, technical component that would let them to connect from on-premises to cloud, they wanted to make sure they have high availability again. They had another requirement where they wanted to inspect traffic going in and out of a specific region, and we were able to meet that with using a network virtual appliance and using UDR. And the network virtual appliance they chose in that case was Palo Alto. Right? Design considerations, the way we did was, I mean, it's a complex requirement, and the way we did was we broke those requirements into multiple small chunks, and we did workshops on all those small chunks and had them think about, okay, what this feature, let's say a VNet feature, means to you, and how do you want to, what does that mean to your business requirements, and how does that fit in your technical requirements? So we did it for all these components, and we're able to tackle that and manage the bigger problem. And like I said, we used NVA for that. Connectivity, we were able to come up with VNet to VNet connection option. Again, redundancy was the big thing. So the whole point of this particular customer's exercise was all about providing redundancy all the way from their on-premises through the connectivity partner that we went through, and then to Azure as well. So how did we do that? First, we took our Azure side, Azure region, which is Europe North, created a virtual network, which is Hub VNet, and then created spoke VNets based on the projects and connected them through VNet peering. And once we did that, we connected that region with their on-premise location through the London Meet Me point. Right? Now, because they wanted redundancy, we built pretty much a similar infrastructure in the Europe West disaster recovery, Europe West region as disaster recovery zone, right? And then to connect that, we partnered with another ExpressRoute provider and connected them all the way from their another location where they have another data center through a different peering location, this time through Paris, and connected that to Europe West. So if you look at it from the right side, you'll see we've got redundancy in terms of regions where they had, should Europe North fail, they could fail over to Europe West, and they have the infrastructure running. And in terms of connectivity, they have dual ExpressRoute link connecting each of these regions all the way back to on-premises. Right? Once they were happy with that, we moved into the next region, which is Southeast Asia, where they started doing dev test, and they didn't have ExpressRoute at that time because it was pre-prod. And the way we made sure this is also connected is by using VNet to VNet connection. Right. So a couple of quick technical points. I want to make sure you get this one right. So Bala talked about VNet to VNet connection option. So one is through explicitly connecting, like Southeast Asia, connecting to the other regions using VPN gateway. But if you notice that there is no direct explicit connection between Europe North and Europe West, and that's because, want to refresh your memory, that because the ExpressRoute gateway, ExpressRoute link, so if you have multiple virtual networks connecting through the same ExpressRoute link, that is equal to connectivity between these virtual networks. So that's a good point to mention here. The second one is there isn't really, so this is another point that we tend to miss a lot, is where, say, if you see Southeast Asia coming and connecting to the other regions, it makes you think that then Southeast Asia might be able to use the connection that is available in these regions and connect to on-prem, which is not the case. So, because there is no explicit routing that is possible between a VPN gateway and an ExpressRoute gateway. So think about it when you have to do this, and there are multiple ways to tackle that, but want to make sure that you don't assume that the connection can be used because there is pretty good connectivity between these regions. All right, with that, let's move to the second scenario.
Okay, thanks, Balaji. Let me run through another customer scenario. This is also somewhere in Europe, Spain. This is their current on-prem deployment. Looks like basically they have a data center, and what they are trying to do is trying to shut down the data center. They want to move everything to the cloud. Then their on-prem basically has two types of connectivity. They have MPLS connection from other offices, and there are also some remote locations that connect to the data center using site-to-site VPN tunnels, right? What they are saying is, hey, this building is going away. That means whatever is here, all these servers will have to move to cloud. That's their goal. But at the same time, I need to make sure a full routing capability between all locations. So I want to make sure cloud as the central location instead of the physical data center, and I need to make sure that I have full connectivity, and whatever connectivity options that you are proposing, I'm also talking to a competitor, make sure your offering is much better, right? And as I said, they want full routing between their remote locations that are coming through the site-to-site location, and also whatever is in their MPLS connected locations, they also need to talk to each other. So they want full routing everywhere, and anytime any traffic goes from any of their on-prem location into cloud, they need to make sure that it is protected with a firewall, and I need to make sure that the segregation of duties, like people who are going to manage those asserts, they will be able to do that, and they will be able to pay for it, but I, as an IT guy, will provide the connectivity part and the security aspect of it. I need that kind of flexibility. So we talked about two models. How do I do? Can I just put everything in one VNet, or do I do that in multiple VNets? We talked about this earlier. So in this case, we chose the right-hand side model, multiple VNet, and that's how we are able to segregate duties and have a central control for the site-to-site connection, and so that requirement is taken care. And then second one is any time the traffic leaves on-prem and go to cloud or coming back, it has to be inspected. So what is that we need? Obviously, you need the ER gateway to connect to the enterprise location, and for this, I need to create a NVA subnet and make it highly available, and I need to be able to do UDR for any traffic coming in. To reach any of these, it has to go through this UDR and go through the NVA. And similarly, in all the subnets, I need to have an UDR and say anytime this guy wants to talk to this one, I need to apply a UDR in each of those, and then to make it go through that. So the second constraint is also taken care. And we talked about remote locations coming through VPN. There are 25 locations of that. And what do I need to make it happen here? Obviously, I need a VPN gateway, and I chose a high-performance VPN gateway SKU because it can connect up to 30 VPN tunnels. I have 25 sites, so this SKU can take care of it. So all these remote offices can connect through this one. And last but not least is the actual enabling full routing across their MPLS network between all the locations. They should be able to, whether they come through VPN or whether they come through ER, they should be able to talk to each other. So how do we do that part? Balaji talked about a scenario. The easiest thing is if the VPN connection is terminated on the VPN gateway, probably they can go through this ExpressRoute gateway and reach their enterprise. But this is the ideal path, but it is not available today. And basically, we are working on it to make sure the routes between ER gateway and VPN gateway are shared. So since it is not available, what else I can do? There are two options. One, I can make all these VPN gateway go to the MPLS provider, and they provide the VPN service, and they all come through the ExpressRoute circuit into on-prem. I don't even need to have this VPN gateway in Azure. But they looked at the cost and say, hey, VPN in Azure is much cheaper for me. So what I would do is I will also connect my on-prem the MPLS locations. I will initiate a VPN connection to the same VPN gateway. So all these locations can also talk through the green line to the remote locations, and these guys can also talk to the departmental network, and these departments can talk to these guys, and these guys can also talk to. So I can have a full connectivity. So that's the reason I'm showing this in LO. It's not ideal, but I'm still providing an option, but we are still working on it, and we will be able to do that in the subsequent months. Okay. And then the other thing is improve connection from remote offices. They have branch offices in South America location, and currently the way they connect to their head office is through an internet VPN connection. So the locations here, they don't have good internet connectivity, and so their connectivity are not very reliable, and so they wanted some other options. And what is that they can do? Probably they can also VPN to the Azure endpoint that they are going to have, but again, it will go through the same long VPN route, and they will have the same problem. Instead, what we suggested is, hey, create a VNet in the nearest US location and create a cross-link these two, because it is all going through Microsoft Backbone, and you will be able to do. So how do I connect to these locations? Can I use ExpressRoute or can I use VPN? Because it's all small offices, they didn't want to go through ExpressRoute. They said we will still do VPN, and they connect to a VNet in Texas, and so they are able to reach through Microsoft Backbone and reach their data center in the VNet in Europe side. Moreover, they also added some additional services so that these guys, they don't have to go for this long route everywhere, so they can deploy some services in this VNet itself. That way they just connect it through the local shortest VPN connection. So that's the overall design, so I'm able to improve the remote office connectivity also. And this is the final diagram that we put together for this customer's deployment. That's all I have, and I think I showed this demo yesterday, so I'm skipping it for the time. So if you have any questions, I'll be here. I'll be happy to answer any questions you may have. Oh, okay. The previous one. Oh, sorry. Thank you.